Problem 4. Integral from 0 to pi over 4 of tangent to the fourth power of x, secant to the fourth power of x dx. Again, no simple rule for this. Use substitution won't work. So we're going to use our trig identities. And we have two choices, which makes this a little difficult. Secant squared of x is equal to 1 plus tan squared of x, or tangent squared of x is equal to secant squared of x minus 1. So looking down the road, we have two choices. U could end up being the tan of x, with the derivative being secant squared of x dx, or U could be secant of x, and the derivative would be secant x tan of x dx. So separate those out. For u tan and du secant squared, you'd be saving a secant squared at the back, which would leave you tan 4 secant squared. On the other hand, if you yet let u be secant x, you'd have to borrow a secant and a tan, so you'd end up with tan cubed, secant tan. So if you take a look, using the trig identity, you really can't use the second one because turning tan cubed or secant cubed into anything else is impossible. So we're going to be using the top one, tangent to the fourth, secant squared, and eventually we will be letting u be tan and du being secant squared. So we'll separate out tangent fourth, secant squared, and we'll trade that one secant squared right after the tan fourth into 1 plus tan squared. So you get the integral of tan to the fourth x times 1 plus tangent squared of x rather than that secant squared. And again, we're leaving the secant squared of x dx on the back for our use substitution. We do a distribution, and we get tan to the fourth power plus tan to the sixth power of x, being both multiplied by secant squared of x. And we'll separate those into two separate integrals. So you have the integral of tan to the fourth, secant squared of x dx, plus tan to the sixth power of x, secant squared of x dx. And again, from the previous page, we had tan to the fourth, secant squared of x dx, plus the second integral, tan to the sixth power of x, secant squared of x dx. We let u be tan of x in both cases, du being secant squared of x dx, and we end up with the two integrals after we do our u substitution of the integral of u to the fourth du plus u to the sixth du. Using the power rule, we get u to the fifth over 5 plus u to the seventh over 7, and we get a final answer of tan to the fifth power of x over 5 plus tan to the seventh power of x over 7. And let's not forget that this was a direct evaluation from 0 to pi over 4. So we had a definite integral, and we get an answer of 12 over 35.